Yeah, hello together. Welcome also from my side. We will talk today about the capability that a solution space or noun solution space can bring to you to give all of us the same understanding of a solution space. We will just walk into what is a solution space to get a common understanding. Then we will go into some use cases for engineers, production and stock planners, as well end users, and see how the noun solution space can be used to increase daily work of these different people. So I would like to start with introduce a bit the solution space. Maybe it's for some of you already known what a solution space is, but just that we all have a common understanding of it, I would like to guide you quickly through the creation of a solution space. So when we think about a configuration, we typically have a number of characteristics. So that's something we typically add in the authoring environment into our configuration engine. So we define characteristics with certain values. In this example, we have two characteristics with the values A, B, and C, and the other one X, Y, and Z. So these characteristics will create the theoretical possible combinations of your configuration. So here highlighted in the green circle or in the table below. And very often we can't sell all the possible combinations, so we apply some rules to the system. And by applying some rules, like here, we're defining the A value of the characteristic 1 can't be combined with the X of the characteristic 2. We're defining what is our valid solution space. So that means certain combinations will be restricted. They are not possible to build, and others are possible to build and hopefully later on also to sell. So we're building our valid solution space and our invalid solution space. So that's what happens typically in the modeling environment by defining characteristics and related rules to it. And now when we use our configuration engine, by selecting certain characteristics, we will navigate in the valid solution space, and we will restrict the valid solution space step by step down to have a complete configuration. And the configuration engine of course guides us through this process. So let's say we use our configuration engine here, and we do a selection of the characteristic 1 value A. That means we're restricting now the valid solutions to the one where characteristic A is valid. So that would be the blue one over here and in the table down here. So that's our partial valid solution space. And as we typically have not two characteristics, we might have hundreds of characteristics. We step by step reducing this partial solution space toward a complete configuration. So now when we select the second characteristic, for example, the Y, then we would get into a complete configuration here. And today we will talk mostly about the partial valid solution space and the valid solution space and how we can use these areas to increase certain productivity and in the daily life of different employees. But now let's consider about these valid solution space as the engineering solution space. So that's what the engineering people have defined and what can be technical built. So having our engineering solution space, typically we want to sell our products. And to be able to sell it, we have to apply to certain laws, regulations in different countries. So there is a difference between what I can engineer and what I can sell in certain markets. So there might be local restrictions in some countries where I can't sell all combinations. There might be upselling reasons that certain combinations only can be selected together. And there might be also local preferences of different markets where it makes no sense to offer certain configurations. And these rules will be typically applied on top of the engineering rules. So we have another dimension, the market over here. And when we now apply some regional rules or some sales related rules, for example, that in Germany, I'm not allowed to sell the value A of the characteristic 1. So that means we have for Germany an even smaller solution space of sellable configurations. And that might look different for different regions or countries. So for example, in the US, I'm only allowed to select the value B of the characteristic one. So A and C isn't allowed to be sold in the US. Or in China, there might be a restriction that I can't offer the combination of A and Y in China. So all these different countries have now different solution spaces, and I'm only allowed to sell in these countries a specific solution space. That means our possible combinations will be now increased with the information of the market. So you can see different configurations can be offered in different markets. But what we also can see here is that there are some combinations we can't offer in any of these markets here. In these examples, just 3. You might have more markets typically, but it can happen quite soon that there could be configurations you can't sell in all the markets. And that's of course a problem, because you can engineer it, and maybe you already have engineered it, but you can't sell it. And that's of course a problem. And that also leads us to our first use case. But before we go into the first use case, let's recap on how have we figured out that there is a configuration we can't sell. And the reason for that is that we know the solution space. We could see it. We could see that which combinations are allowed and which were not. If I just would hand over the rules to you, for example, which of the rules of the different countries and the engineering rules, then you would have a hard time to figure that out. And that's the problem of the most configuration engines on the market, that they are kind of black box. They don't know all the combinations. They just can validate certain configurations. And that's what we would like to talk about today. So what do we need to identify such situations in different areas? We would need to know all the possible combinations of our product models. That means it would be nice if you could have a database with all the valid combinations in it. And it would be also nice if you could just execute a kind of a query against this database by saying what characteristics I'm interested in, so what combinations I'm interested in, from which model, and under which condition. For example, for a specific market, give me all the combinations for the German market, or give me all the combinations where the audio system is selected, or something like that. So that way you could run queries against it, and you would expect to get returned a table view with all these possible combinations from the database. And that's our today topic. You can replace the database with all the possible combinations with our VT technology, because this technology contains all the possible combinations after we have compiled the rule set. And you can replace the query with our Solution Space Explorer. And the Solution Space Explorer is a small UI which helps you to create these queries and return or get the table of the possible combinations visualized. But underneath, there's also an API you can use so that you also can request these combinations. So that's a little bit the frame here. And let's go back to our use case we had before, that we have now found some over-engineered elements. So some combinations, you maybe have invested time in engineering the specific parts, but you are not allowed to sell in any of your markets. And that's, of course, something you would like to avoid, as you wasting just time and effort. So let's go into the first use case and talk about what benefits could I have as an engineer from a known solution space. And yeah, so the topic is in finding and avoiding over-engineering, or maybe someone might also talk about a no-runner, because if you can't sell it, you're pretty sure we'll have no sold variants of these combinations. For this example, we will take a small product model, and we all know the today steering wheels. They have typically buttons on the left and the right-hand side. for controlling, for example, the distance control or controlling the multimedia system. They can have, of course, different materials, here plastic A, B, and carbon, and they might have also different shapes. So there are some combinations related to these different options you can have. And you can also imagine that there could be configurations where you don't need the left-hand buttons. For example, if you don't have a distance control, you don't need the buttons. So that creates some variance for this middle cover part here of the steering wheel. And that's something we would like to look in. How does it look from an engineering point of view? And how does it look from a sales point of view when you have applied some additional sales rules? What you can see here on the left-hand side is our solution space explorer. And that one can be used to create such queries against the valid solution space and get returned the possible combinations for your query parameters. So let me start the video here. We have recorded that session. So you can see it's an engineering model on top for the solution space. You can define which version you would like to use, which product model you would run the query against, optional the output language. And here you can specify which variables you are interested in. So by selecting, for example, here the left and right button, the shape and the material, you specify I would like to have all the combinations possible between these four variables. Optional, you can specify the validity date you would like to look in, and you can also specify some queries, for example, to define, show me all the combinations just relevant for the German market. And now you can request the possible combinations, and you can see here now all the possible combinations the engineering model allows. These are 24 possible combinations. If you want, you can also download it as an Excel sheet if you would like to use it in Excel, do some analysis on top of that. That's also possible. So that's now our engineering space. Let's do the same with a more or less same model, but with some sales rules applied to it. And sales rules are here that some laws define that the distance control is mandatory, some rules defining that carbon design or material is only available with the sports wheel, and if you have the sports wheel, you automatically have the audio control system. So that's some rules which are applied and which will reduce the possible solution space. And it's an example of our sales model here. So running the same query, but against a different model, that's the sales view or the sales model, which combines the engineering and the sales rules. The same characteristics we want to request, but you also can see here are the additional characteristics for the sport package and the multimedia system. And optional also, again, the capabilities to define the context. And when we now run these again, you can see that just 5 combinations are left. I said you can also download it. And that means we have a delta here of 19 combinations between the engineering and the sales model. So 19 possible variants of a mechanical part here of this middle cover you would manufacture but can't be sold. And that's of course a bigger problem. And how can it happen that you have this over engineering? The reasons for that might be that you do not have a combined model. So if you have both models in separate systems, like in a PLM system, the engineering view, and in a sales system, the sales view, your engineering people can't know about the possible sold variants or what is allowed in which markets. They just see the engineering space. Another reason could be that you create the sales view after you are done with the engineering. And also then, even when you have a combined model, your engineers working with the engineering space, creating all the variants needed to manufacture these variants. And then later on top, it will be restricted down to what you can sell. And another reason is that you typically don't know the solution space. So you typically don't have the capability to run such queries against the configuration engine. But with our VT technology, we are able to offer you this view on your configuration and output the possible combinations here. And this, of course, has some benefits, and it's mainly in reducing your engineering effort. It reduces your manufacturing planning effort because there are variants you don't need to plan for, and it can also reduce your parts and stock costs. So that's some benefits you can get as an engineer, and there are some other capabilities you can use this information for as an engineer. And I have used here two examples, and one is the automation of simulations, for example. So in the software development, it is quite usual that you have continuous integration and that you can execute certain processes automatically. But with this process, you could also request the possible combinations of your solution space. For example, for a crash test, there are certain characteristics relevant, and there are many characteristics which are quite unimportant. So, for example, the color of the car or the fabric of the seat. These are not information relevant for a crash test simulation. But the shape of the car, the engine type, the seat type, these are all important characteristics and combinations which are relevant. And maybe some combinations are not allowed, like a diesel engine diesel engine can be not used with the 3 doors variant or whatever. So receiving this solution space in a similar way we have seen that before, you could use this information, the possible combination, run that into the design automation process, get the 3D models out, put that into the crash test simulation, and receive a report. So that way, by getting, sorry, there was something. That way, by receiving by receiving the possible combinations, you could run this process through and automate this process. And whenever the configuration is changed, you just rerun the whole pipeline. Or if you change the 3D models, the cut data, you also could rerun it and test it again with all the possible combinations of your product model. And a similar thing could apply by certification of products. So there might be different rules, for example, in the medical industry to certificate your products and register your products. So you could also build these possible combinations for the different markets which are relevant and run the registration process or certification process for your products. So that way, with the help of the known solution space and the combinations, you can also automate and improve such processes. Going forward, as a production and stock planner, so having the world where you're offering your products, having some production sites which cover certain regions. So for example, one production site for North South America, one for European, Africa, and one Asia and Australian. And also having some stocks which covers the areas where the factories are not available. So how great would it be if you know what combinations you're offering in which market, and you could improve your production to the local relevant combinations. And you also could improve your stock keeping units to what is really relevant in this market. So you don't need to keep any materials on stock which you only can sell in Asia, for example, in the American stock. So that way you can also optimize with the known solution space what are the parts and combinations you're offering in the different market, and to optimize these stock keeping and production areas. If you would like to know a bit more about that, there is a white paper on our website you can download where also some ROE calculation is in. As a last use case, I would like to run through an end user use case. So we have now seen how the known solution space can improve your internal productivity in the company, but you also could offer access to the possible combinations to an end user to help guidance through the configuration process. And for that, I have picked one typical situation, a product finder, where you would like to filter down based on some characteristics to a product for a specific use case. A very normal use case for a component business where you would like to sell a component. And what we see very often when we talk to component companies is there are the stock or catalog or noun variants items you have. They have noun material numbers, and they are typically generated for paper catalogs or for stock keeping units. So there are a bunch of configurations you pre-create to handle, to offer them in the catalog, and also to have some stock keeping unit for these. But very often that's just a smaller part of what you really can build. Typically, there's also a configure to order space where product manager has taken the stock items from and has defined these are the options we would like to keep on stock or offer in a catalog. But there might be more you can deliver. So that's the configure to order space. You might have not a material number for these configurations, but all the rest is already engineered and available. And then there might be some configurations which need some approval. So you're pretty sure you can deliver on these. So it wouldn't be a technical problem, but you maybe have not created all the artifacts already. So maybe you have to adapt some CAD drawings, or you have to adapt the BOM bill of material for these configurations. So there might be some options you have not yet finalized, but you are pretty sure you can deliver on that as well. So that's very often a situation I can see in a component business. And what happens, well, I missed one, sorry. Of course, the engineering to order is also important, but that's of course not in the noun space. That's on top, having some requests for unknown combinations. What now very often happens is that these stock keeping units, where you have the material numbers, are stored in a database. And then you put a product finder on top and offer these combinations to an end user. So that the end user can, as in a paper catalog, go through the noun variants or the catalog items. So an end user will access this product finder to find the product, and there can be now different situations. One situation would be, of course, the best. He finds what he was looking for, he buys it, and he has a fast delivery time. But in case he don't find it, if he is in the configure to order space or in the approval needed space, or even engineering to order, he has to run the ETO request. So the delivery time is unknown, and you have to handle that request. Even when it is a configure to order request, you might have some extra work to do to figure that out. And of course, there is a risk that you lost people on this road. So they might look into your product finder, they don't find what they was looking for, so they go to the next vendor, and maybe they find there something. So it might be also that you lost some people, and that's of course bad if that happens. So how can we improve this process? By compiling all these different variants you have into our solution space, you would have all these three kinds of configurations available. Of course, with a small identifier flag on it, but you know which of these variants are in stock, which of these variants are configured to order, and which of these variants require an additional approval. The front end might be exactly the same as you have seen before. So it will be still the product finder, so you get a similar user experience as with the database approach. But the difference will be now that you can offer a lot more configurations to your end users. Not only the dark green one, you can also offer the light green and the orange one to a user here. And now when a user decides for a certain configuration, he could end up in a stock keeping item and directly order it. It could be a CTO one where you might need only to create a variant number for it, and then all the rest can be already derived and executed in manufacturing. There might be the technical check, which would be a kind of fast lane for engineering to order. So you know what you have to do. You only need to adapt certain technical information, and then you could run it like a CTO. And of course, there might be still some ETO requests for very special use cases. But it's a reduced amount of ETO compared to the one before. And you most likely will also reduce your loss rate as you're offering more variants to the end user, and it's more likely that he finds what he was looking for. So that way you can reduce the loss rate, reduce the ETO rate, and yeah, improve the guidance of the user. And we have prepared one example for that. So we're using a component here, an industrial temperature sensor. It has some variants like the housing, the signal transfer, the protection level, sensor pipe, sensor, and so on. So it's a typical component. It's used in industrial plants to measure temperature in different locations. You could offer that as a classical configuration view where you have groups and characteristics you can select, but that's not what users of a user who want to buy a component expect. They expect a bit more the typical product finder approach where you have some filtering and a table below where you can see what combinations you can sell and then pick from them. And that's what the Solution Space Explorer or the API also offers, that you can use this information in a product finder. So we have created here one example, and I will start this as well. So it's a wizard here where you first define your use case. So you would like to use it in a chemical industry, in an explosion area, for example, and you would like to measure some medium in a pipe. So you specify a little bit the use case to reduce already the possible solution space to an amount which is handleable. Now you can see here in the middle the possible combinations left. It's 360 for this example. It's limited to 200, so you can define what the limit should be. In this case, it's limited to 200. You have the filters on top, the solution space in the table, and here you can see the status. So these one are some stock keeping units that has a card icon here. And when we scroll a little bit down, you can see these one here are the configure to order products. So it might require some material number, but the rest is already defined. And here you have also the request parts. And additionally to that, if really the customer does not find what he was looking for, down here you have a request button for requesting engineering to order. And now you can work with the configuration in a similar way as you are used with a product finder. You can select some filter and the list will be reduced to what is possible. So in this case, from 360 to 240. And yeah, by selecting more and more, the list will become smaller and smaller. So 60 left, and you can see it reacts as a database. You don't see that it's behind a professional configuration engine. It behaves a bit like a database. And that's the way how we can support these configuration, these product finder processes also with a professional configuration engine. Of course, you can also solve some conflicts. So there are some options not available anymore based on the selections you have done. And you can, as people who use our VT technology are used to, you get a conflict resolution here. So if you would like to get just the IP65, you have to remove the use case environment for the explosion area because this IP65 does not have any X certification. So you could keep on this combination, or you can undo and return to the previous one. Yeah, and of course, at the end, you might select one of these left combinations here, and you would continue with the order process. In case it's a stock keeping unit, it could directly go into the web shop and you could order it. In case of a CTO, it might take a slightly different path. And in case of a request, it might create some requests in your CRM system that there are people interested in some special cases. And that's the way the noun solution space can be also used for an end user to guide through this process. Yeah, that's a bit the use cases we have prepared. There are, of course, many more use cases, and maybe you have ideas for some use cases. Yeah, so I think we are half hour. Back to you.
Yeah, I'm back with the Q&A part. Exactly, we're running a bit short in time, so I think it's fair to have at least one question here before we close. So
yeah.
the question I can read here, Heiko, is can I only use the solution space in your products, or is there also an API available to access this information?
Yeah, so what we have seen here is also available via an API. So you can use our internal solution space explorer for engineering purpose, for example. But if you would like to bring it into a custom front end or support some automated processes, you can use the API and request the solution space also via the API.
Here's another question saying, can I request the full solution space?
I would answer that with a yes and a no. It for typical configurations, and we have configurations with a amount of 10, higher 50 possible combinations and even more. Of course, it would be a data amount. It would be very hard to handle. So very often you have some windows you define where you are interested in certain combinations. We have internally all the possible combinations, but we do not store it as a kind of database or table. We have in the binary decision diagram how we store that. That's very compact representation. So yeah, theoretically it might be possible, but the amount of data you would get back as a table would be maybe too much. However, if you have larger requests, there are also capabilities to limit the requests, as we have seen. We had 360 possible combinations and we have limited to 200. Or you can also page through the results with some paging functionalities to handle these large amount of combinations.